Let us solve this question. In this circuit shown, we have two resistors, R1 and R2, and which are connected in series to a DC voltage source, and we are asked to find the following: the equivalent resistance, the total current, the voltage across each resistor, which is V1 and V2, and the power of each resistor P1 and P2, and the total power or P total. So we have four things to find, which are equivalent resistance, current, voltage, and what? Power. So let us start with the equivalent resistance. First, in this circuit, there are two resistors. The first resistor is 2 ohms, and the second resistor is 4 ohms. And to identify whether these resistors are in series, we look at the connection, right? So from the voltage source, the current flows through the first resistor, which is 2 ohms resistor, and then through 4 ohms resistor. And this shows what? This shows there is only one path for current to flow. From what? From R1 to R2. So this is connection of resistor is this resistor is connected in what? In series combination. Since, as we know, since there is only one path, these resistors are connected in series. And in a series circuit, we know that the equivalent resistance is equal to the sum of the resistances. So here R equivalent is equal to R1 plus R2, and in resistor 1 we have 2 ohms, and in resistor 2 we have what? 4 ohms. So R equivalent is equal to 2 ohms plus 4 ohms, which is gives us 6 ohms. Now this circuit can be replaced by a single resistor of which is 6 ohms resistor, which is, we call this R equivalent, right? So 6 ohms resistor connected to the voltage source, so it is a single resistor. And let us solve the second equation, which is the total current. So as we know, in series, the current is what? The current is the same through all resistors. So the current through the 2 ohms is same as the current through 4 ohms. So we know that I total is equal to I1 is equal to I2. To find the current, we divide the total voltage by the equivalent resistance. So I total, or I, is equal to V divided by what? R equivalent, which is equal to 12 volts 12 volts divided by what? 6 ohms. And we get R equivalent from what? From the last equation. So we can say I is equal to 2 amperes. This means the current through resistor 1 is 2 ohms, and also the current through 4 ohms is what? 2 ampere. Now let us solve for the third question. So the third question is, find the voltage across each resistors, which is V1 and the V2. So we use the voltage divider rule, or Ohm's rule, or Ohm's law, to calculate the voltage. So in this case, I use the voltage divider rule. So you can use Ohm's law rule, then you can get the V1 and the V2. So as we know, V1 is across what? Across 2 ohms, and V2 V2 is what? V2 is across 4 ohms. So 4 ohm resistor. So we know that V1 is equal to fraction of R1 over R1 plus R2, or total resistance, which is equivalent resistance, and multiplied by what? V total. And this is V1 is equal to, we have R1 2 ohms, so 2 ohms divided by 2 ohms plus 4 ohms, and we multiplied this by what? By 12 volts, which is total voltage, or V from source, so voltage from source. And which gives us what? Gives us 2 ohms divided by 6 ohms, right? Then we get what? We get then we multiply by 12 volts, then we get which is equal to what? And it gives us what? Gives us 4 volts. And let us do for let us calculate for V2. As we know, we calculate it as what? As V2 is equal to the fraction of R2 over R1 plus R2, or which is total resistance or equivalent resistance, and we multiplied this by total voltage, and we saw V2 is equal to 4 ohms divided by 2 ohm plus 4 ohms multiplied by 12 volts, and which is gives us what? 4 ohms over 6 ohms multiplied by what? 12 volts, and which is this gives us 8 ohms, 8 volts. And we get what? We get 2 V1 and the V2. Then let us solve for question 4. which is question 4 says find the power of each resistor and the total power. So as we know, power or P is equal to current squared multiplied by resistance, and this means for P1, P1 is equal to current squared multiplied by R1 or resistance of resistor 1. As we know, our current is 2 amperes, so P1 is equal to what? 2 squared multiplied by 2 ohms, and which is this gives us what? 8 watts. 8 watts. And for P2 is equal to current squared multiplied by resistance of resistor 2, sorry, and so P2 is equal to 2 squared, which is current is 2 amperes, so we squared the current, so we get 2 squared multiplied by 4 ohms, and which is this is gives us what? Gives us 60 watt, 16 watts. And now what is left is what? The total power or P total. Simply, P total is equal to P1 plus P2. So, which is P total is equal to 8 watt plus 16 watts, which is gives us what? Gives us 24 watts. So we can check this. You can use the other formulas for to find the which is P1, P2, and the P total. Let us use the other formula, which is we can check also. We can also check the total power using the other power formula. So P or power is equal to voltage multiplied by current. So total power is equal to total voltage multiplied by total current, which is P total or total power is equal to 12 volts times what? Times we have 2 ampere, 2 amperes, so times 2 amperes, and we again get what? Get 24 watts, which is same as above. So in this question, we have successfully found the equivalent resistance and the total current and voltage across resistors and the power of each resistor.